In this video, we will continue practicing how to graph sine functions and cosine functions, including changes in amplitude, vertical shifts, and phase shifts. So looking at problem number 12, I see that I've got my A value right here, and that tells me that the amplitude is going to be 2. Now how about the period? The B value goes right here. Now there is no visible B value, in other words the B value is 1, but that tells me that the period is just going to be 2 pi. That's the usual period. Now there is a phase shift. My H value is right here. The H value is going to give us the phase shift. Now when there is no B value, you can just look right at this to see what the phase shift is. So the phase shift will be pi over 2. It's the opposite direction from what you might think. Positive pi over 2 is actually a phase shift to the left. So this will be pi over 2 to the left. Now there is no K value. The K value would go right here, and there's no number here. So that means there is no vertical translation. Alright, that should give us the information we need to do the graph. As we begin the graph, the first thing I will look at is the period. So the period is 2 pi. So I'm going to come way over here to the right, and I will go ahead and put 2 pi. So if I go halfway, that'll be pi. If I go half again, that will be pi over 2. If I go to this third position, that will be 3 pi over 2. Okay, now let's look at the amplitude. Since there is no vertical translation, that means the x-axis is still going to be the midline. So I can go ahead and use the amplitude as I think about what will be the highest point on the graph and what will be the lowest point on the graph, positive 2 and negative 2. Okay, there is a phase shift, but we will first go ahead and do the graph without the phase shift. So this is a sine function, and we know that a sine function starts at the midline, and then it goes up to its highest point, falls back to the midline, then it drops to its lowest point, and back to the midline. So this is what the graph would look like if there was no phase shift. But there is a phase shift, which is pi over 2 to the left. So we need to think about that. It would be helpful if we could see on this scale how big is pi over 2. And it's going to be really easy in this case because we see pi over 2 is one of the marks that we just created. So because we see pi over 2 right here, that means that one space on this graph, one jump, is pi over 2. So that means if I'm going to move all of these points pi over 2 to the left, that means I'm moving each one of these one space, one position to the left. So I don't have any markings over here, so I should go ahead and go pi over 2 to the left as well. And of course if I go pi over 2 to the left, that makes this negative pi over 2. Alright, so because I'm moving an entire space, an entire position, I'm not going to need any new values in between. I can just use the labels on the x-axis that I already have. So here I go. I'm going to start with my first point, and I'm going to move it pi over 2 to the left, so it's going to land right here. And now really I could just go through the pattern of the sine curve, and knowing that the sine goes up to its highest point, falls to the midline, drops down to its lowest point, and rises back to the midline. Or you could look at each point one by one and imagine sliding it to the left one space. Alright, either way, this is what the final graph is going to look like. So that is it for problem number 12. Alright, number 13. The A value is right here, so the amplitude is going to be 2. The B value would be right here, but there is no value there. So that means the period is just going to be 2 pi, like normal. Phase shift. In the absence of a B value, you don't have to worry about factoring it out or anything, so you can just look right here. This is my H value, and the H value tells you the phase shift. It's the opposite direction from what you might think, so it is going to be a phase shift of pi over 2. But plus pi over 2 is pi over 2 to the left. Now this problem has a K value, and the K value tells you the vertical translation. So minus 3 is a vertical translation of down 3. So that should be enough information for us to sketch the graph. When I get ready to sketch a graph, the first thing I look at is the period. Since the period here is 2 pi, then I'm going to come way over here and put a mark and call it 2 pi. Halfway is going to be pi. Half again will be pi over 2. And in the third position, this will be 3 pi over 2. Alright, now when there is a vertical translation, you have to look at that now. So since we have a vertical translation of down 3, okay, I'm going to need to mark that off on the y-axis. So alright, as I'm choosing my markings, I'm also looking at my amplitude, because in my mind I know that wherever I put this midline that I'm about to draw, I'm going to have to go up 2 and down 2 because of the amplitude. So my midline, vertical translation down 3, so I need to label this. So I have -1, -2, -3. This is where my midline will be. I'm going to go ahead and put -4 and -5, label that as well. So I'm going to draw the midline as a dotted line. You should do the same. So here we are at -3 because we shifted down 3. So I'm going to draw this dotted line. Okay, always show the midline as a dotted line. Okay, so I'm going to treat that the same way that I have treated the x-axis in the past. So the next thing I'm going to look at is what kind of function do I have. So this is the sine function. So we know that the sine function starts off at the midline. So I'm going to put my first dot right here, and then I know the sine function will go up to its highest point. Now remember that the amplitude is 2. So that means I'm going to go up 2. So I'm going to land here at -1 when I do that. So it's going to go up to its highest point, and then it will fall back to the midline, and then in the next position it will fall to its lowest point, and then back to the midline. So this is exactly what the graph would look like if there was no phase shift. However, there is a phase shift, and is pi over 2 to the left. So I need to take all of these points and move them pi over 2 to the left. Now in this case I'm noticing that pi over 2 is one of the numbers on my x-axis that I've already labeled. That's useful because it tells me on this scale how big pi over 2 is. And so I can see that pi over 2 is one space on this scale, one jump. So I'm going to have to move all of these points one position to the left, one full position. So I'm just going to need one additional mark to the left of my y-axis. So I'll go ahead and put this here. And of course, if I'm moving to the left, pi over 2, that makes this position negative pi over 2. Alright, so this is how far I need to move everything. Let's start with the very first point. If I move this to the left, pi over 2, it's going to be here. Now after that, I can just follow the usual pattern of the sine function. I can go up to its highest point and then fall back to the midline. And then I can go down to its lowest point and return to the midline. So these blue points represent what the actual graph is going to look like. And that's it. That's what the graph should look like for number 13. Alright, for number 14, I'm noticing that we have a B value and we also have a phase shift that is trying to happen. Whenever I have a B value and a wannabe phase shift, I have to factor this B value outside of the parentheses before I can interpret the equation properly. Like this 1/2 needs to get out. So let me do that first before I do anything else. Okay, so let me recreate the scene of the crime here. So we have 1/2 x plus pi over 2. But I need to factor that 1/2 outside of parentheses somehow. Now I can do that if I divide both of these by the thing I'm factoring out. So if I divide by 1/2, then that will tell me what I have inside. Now if I divide the first term by 1/2, these just cancel out and I just have x. But what is pi over 2 divided by 1/2? Well, when you are dividing with fractions, you multiply by the reciprocal. So this is the same thing as pi over 2 times 2 over 1. I'm multiplying by the reciprocal. So this is 2 pi over 2, and those 2's cancel out, so you just have pi. So that's why I'm going to have plus pi right here. So this is the form that we have to use to decide what the phase shift is and all of that. So I'm just going to write that down in this form. So I have 1/2 x plus pi. Okay, so I have 4 times the cosine of this. Okay, so this is the form that I'm going to use to interpret what's happening. So this 4 is my A value. So that's going to tell me that the amplitude is 4. This 1/2 is my B value. And that's going to indirectly tell me the period. So remember that the period is always 2 pi divided by that B value. So that means the period is going to be 2 pi divided by 1/2. And again, when you divide by a fraction, you multiply by the reciprocal. So that means that the period is going to be 2 pi times 2. So that means the period is going to be 4 pi. Okay, so the period is 4 pi. Now the phase shift, I see my h value right here is pi. And notice that the phase shift is not pi over 2 the way it looked at first. Once you take the 1/2 outside of the parentheses, you see that the phase shift is actually pi. but it is the opposite direction of what you might think. Plus pi is actually a shift of pi to the left. Alright, so make sure you include that word, pi left. And this is enough information for us to sketch the graph. One more thing, vertical translation. There is no k value, which belongs here. There's no k value, so I know that there is no vertical translation, so I'll just say none. As I go to do the graph, the first thing I look at is the period. I see the period here is 4 pi, so I'm going to come way over here and I'm going to put my 4 pi. Now if I go halfway, I know that that will be 2 pi. If I do half of that, I know that will just be pi. And if I go to the third position, that will be 3 pi. Since there is no vertical translation, the x-axis is going to remain the midline. So I can go ahead and look at the amplitude now as the highest point and the lowest point on the graph. So +4 and -4, we are ready to go. Now this is a cosine function, so if there was no phase shift, the cosine function would start at its highest point, fall to the midline, and then it would go to its lowest point, return to the midline, and end at its highest point again. That is the cosine pattern. However, there is a phase shift on this problem, pi to the left. So it's important to look at your scale, look at the x-axis, see if you can find the phase shift. Sometimes it's one of these numbers that we have, sometimes it's in between. This problem is relatively straightforward because I see that pi is right here. That means that this distance is the phase shift that we're going to do. This distance is pi, one space. So we are going to shift everything one space. Now remember, we're doing pi to the left, so we are going to go one space to the left. I'm going to need another mark over there because I don't have any marks to the left, so I'm going to try to make it about the same distance, and of course if this is pi, then to the left will be -pi. So I'm not going to need any extra marks in between the lines since we're moving each point exactly one space. So if I take this first point and move it to the left one space, then it falls right here. So really I could just go ahead and do the cosine pattern now. I could say, oh, well now it's going to fall to the midline, and then to its lowest value, and back to the midline, and then its highest value. Or I could have looked at it as moving each one of these red points to the left one space. Same thing. Either way, this is going to be the final answer. This is what the actual graph is going to look like. Okay, so that's what your answer should look like for number 14.